Happy New Year, everybody, and in this video we're going to be talking about prime numbers. Especially we're going to be talking about a C++ program that is going to be testing if a number is a prime number or not. So the kind of thing that I'm going to implement is from the definition that you can see on the screen right now, is that a prime number is any number whose GCD with any number less than it but greater than 0 is 1. So taking any number, and if you test to find the greatest common divisor of that number and any other number that is less than it but it's the particular number that you're taking is greater than 1, then the GCD is going to be equal to 1. So if you're going to be able to test throughout all the numbers less than that particular number and find that the GCD is 1, then we're going to conclude that that particular number is a prime number. So let's say we're testing if 11 is a prime, and we're going to do the GCD of 11 when the first number that is less than 10 than 11 is 10, and strictly we will be speaking about integers. So the integer that is less than 11 is 10. So GCD of 10 and 11 is 1. The GCD of 11 and 9 is 1. The GCD of 11 and 8 is 1. And all the ways to GCD of 11 and 2 is 1. The GCD of 11 and 1 is 1. So since all these values mark up to 1, then we're going to conclude that 11 is a prime number. So let's say we're testing 4, if 4 is a prime number. The GCD of 4 and 3 is 1. That turns out to be correct. But if you come to GCD of 4 and 2, the GCD becomes 2. This does not fit the definition of a prime number, since we said that the GCD has to become 1 with any other number that is less than it. So 4 is not a prime number. So in simple terms, that's what we're going to be implementing in the C++ program. So in the coding part, we say this is a C++ program to test if a number is a prime or not, from the concept that the GCD of a prime number and any other number less than it but greater than 0 is 1. So it's the same thing that I've been explaining previously. Now for a test run to make sure that our program runs before any explanations, I'm going to run and then say any common or any common prime number, which is 29, and it say 29 is a prime. Another test run for an even number, let's say an even number like 6, and it says 6 is not a prime. So as you can see, our program is working fine, and all I did is that I created a function that is going to be returning the GCD of two numbers, and the function I named it GCD. It's going to be returning an integer value. It's going to be implementing the Euclidian algorithm, and you can check out my video in the previous week. I posted about the Euclidian algorithm. It's a quick and short video. I hope you can enjoy it, but it's going to be explaining the Euclidean algorithm. So I've just summarized it into a simple C++ function that's going to be returning the GCD of two particular numbers. Then when the program starts, we're going to create two variables. The first one is number, and then the second is an integer that I made it to start from 1. And then I'm going to say to print out that testing if number is prime. That's just to alert the user of what the program is about to do. And then I'm going to see out to alert the user of what is supposed to do, that says enter a number, and then I'm going to accept that particular number. And then since we're going to be comparing from our definition any number that's less than that particular number, and all of them have to be compared, then our particular value of I is going to start from 1, and as long as I is less than that particular number that we've entered, then we're going to find the GCD. If it happens at all at any particular value of I that we find the GCD is not equal to 1, then we are going to end and see out that the particular number is not a prime. Then else, if we are at the end of the program where I is equal to number minus 1, so when I keeps incrementing by one value, it reaches a point where I will be equal to number minus 1. It will never be equal to a point where it's number, but it will be equal to number minus 1. This will be the final round of the loop. And if it's the final round of the loop and in all other previous loops this condition has not been satisfied, that's such that the GCD is not equal to 1, it means that the particular number is a prime, and that all of the values of the GCD of it and the previous numbers which are less than it are equal to 1, which means the particular number is a prime. So we're going to see out the number is a prime, and then that's just how we use the for loop. It's also possible to implement with any other kind of loop. Finally, I'm just going to another test run, and then I'm going to say the number 34. So this is the application of functions, looping, decision making, and the Euclidean algorithm that we've it's really easy. And if you find it a bit confusing, just just comment back and send me your regards about this video, and I'll be glad to hear from you. So have a happy new year, and thank you.